Hello class, today we are looking at the Pythagorean theorem and simplifying radicals. The essential question, how do I find exact lengths by simplifying radicals? Your learning intention. I am learning to find exact lengths of the sides of right triangles and how to simplify radicals. So your warm-up question, you have triangle EFG, which is similar to triangle QRS. The lengths of the sides of EFG are 144, 128, and 112. The length of the smallest side of QRS is 280. What are the lengths of the other two sides? So pause the video and see if you can set up those equivalent fractions. I hope you tried. So if you're looking, this is the smallest and this is the smallest, so we pair them up. Okay, now I choose either one of the two sides to find the next lengths. The 112 and the 128 are on the same triangle, so I will put them together. I'm wanting to know the length on that bigger triangle, so the x goes at the bottom. Now for the math. 128 times 280 divided by 112. Get your calculator out. It can be done in one step. $320. So the length of the middle side is 320. We do the same thing. We have to use the same first radical, or the first ratio, because those are the two sides we actually know. Although now that we know the second one, we could always use 128 over 320. But it's just as easy to go back to the original. 112 over 280 is equal to 144 over x. Once again, the math. 144 times 280 divided by 112. And you get 360. So now we found all the lengths of the bigger triangle. So now let's go into today's lesson. Simplifying radicals is the process of manipulating a radical expression into a simpler or alternate form. So it's a process that we go through. So one of the things that is not well taught in the lower grades is how to find that prime factorization. To simplify your radicals, you must find the prime factorization so you know where your factor pairs are. Remember, squaring and square rooting are opposite operations. So if I've got x squared, that means x times x. The square root of x squared is simply x. So we're looking for those pairs of factors so we can pull one out. Anything that does not have a pair will be left underneath our radical sign. So let's look at the prime factorization of 36. You are always starting with the smallest prime number. I'm going to show you how to do it with the ladder method, because when we get done, it'll look like a ladder. So, to be able to do this quickly, it's helpful to have a calculator. Step 1. Is it divisible by 2? Yes. So I'm going to divide by 2. 36 divided by 2 gives me 18. 36 divided by 2 gives me 18. Is it even? Can I divide by 2? Yes. I now get 9. Is 9 even? No. Can I divide it by 3? Yes. I divide it by 3, I get 3. I know 3 is a prime. 3 divided by 3 is 1. So as you're looking at this ladder, 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So the factors of 36 are 2 times 2 times 3 times 3, or 2 squared times 3 squared. Any questions? Okay, we're looking at 72. Is it even? Can I divide it by 2? Yes. I know it's even because it ends in an even number. 72 divided by 2 is 36. Okay, now I know the rest of it because it's identical to the first one. 36 is divisible by 2, I get 18. I divide by 2 again, I get 9. I divide by 3, I get 3. Divide by 3, I get 1. So this is 2 times 2 times 2 times 3 times 3, or 2 to the third power, 3 squared. Any questions? If you're still kind of confused, back up the video and watch again. Okay, what about 108? Is it even? Yes, it ends in 8. I divide by 2 and I get 54. Okay, 54 is even. I divide by 2 again and I get 27. 27 is not even. Is it divisible by 3? What we look at, 2 plus 7 is 9. 9 is divisible by 3, so 27 is divisible by 3 also. Divide it by 3, I get 9. Divide it by 3, I get 3. 3 is a prime number. Divide it by 3, I get 1. When you get 1 down here, you are done. 1 and done. So I've got 2 times 2 times 3 times 3 times 3. Okay, so the factors are 2 squared times 3 to the third power. Any questions? Okay, let's look at the last one. Pause the video. Can you do the last one on your own? Step 1, is it even? That'll get you started. I hope you tried. So it is even. I'll divide by 2. And you get 630. 630 is even. Divide it by 2 again. I get 315. 3 plus 1 is 4, plus 5 is 9. I can now divide it by 3. I get 105. 1 plus 5 is 6. I can divide it by 3 again, because 6 is divisible by 3. I've got 35. Guess what? 3 plus 5 is 8. Cannot divide it by 3. So I go up to 5. 5 is my next prime. I can divide it by 5. I get 7. 7 is a prime. 7 divided by 7 is 1. 1, and we're done. So I've got 2 times 2 times 3 times 3 times 5 times 7. So this is 2 squared times 3 squared times 5 times 7. Those are the prime factors. When you multiply those numbers together, you will get 1,260. Okay, so let's start looking at the Pythagorean theorem, because the Pythagorean theorem, you've squared everything, and the opposite is to square root. First thing you have to know, are you looking at 2 legs, or are you looking at the hypotenuse and a leg? You look for your right angle. Here's your right angle. Straight across is your hypotenuse. So I've got a leg and the hypotenuse. So if I'm looking at this, I know that I'm going to not be adding but subtracting, because I've got C. So C squared minus A squared is equal to B squared. I'm going to change this around so that I've got the right formula. So C squared, that will be 65 squared minus 33 squared is equal to B squared. So what is 65 squared minus 33 squared? It is 3,136. And that is equal to B squared. Remember, the opposite of squaring is to take the square root. So I'm going to see if this is a perfect square. If it is, then I don't have to worry about the simplification. And I get 56. So it is a perfect square, even though those were big numbers. It's a perfect square. I know that that missing side length is 56. Okay, to find your square root button, here's your x squared button. Right above it in blue is your square root. So you hit the blue button, then your x squared button, and that gives you your square root. Okay, let's try this again. This is my hypotenuse. So I can actually use a squared plus b squared is equal to c squared. So let's set up our equation. 9 squared plus 40 squared is equal to c squared. So 1,681 is equal to c squared. Is it a perfect square? I don't know. Let's see. 1681. It is 41. So when I take the square root of both sides, 41 is equal to c. Okay. So as we're looking, step one. Step one is to decide if we're looking for the hypotenuse or leg. If we're looking for the hypotenuse, we use the original. If we're looking for a leg, we subtract. So let's look at the next one. Here's your right angle. This is your hypotenuse. So I will be adding. 15 squared plus 24 squared is equal to c squared. $801 is equal to c squared. The opposite of squaring is to take the square root. Let's see if it is a perfect square or not. It is not. So that means we now have to simplify this radical. So I'm going to come over here. 801. It is not a perfect square. So it is not even. I cannot divide by 2. Can I divide by 3? 8 plus 1 is 9. It is divisible by 3 because 9 is divisible by 3. I get 2, 6, 7. Is 267 divisible by 3? 2 plus 6 is 8, plus 7 is 15. 15 is divisible by 3, so this is also divisible by 3. I get 89. Guess what? 89 is a prime number. So we are done. So 801, we're looking at the square root of 3 times 3 times 89. You are pairing up. If you've got a pair, you bring one to the outside. So this is the same as 3 square root of 89. And we're done. Okay, any questions? When we're looking to simplify, if we've got a pair, we can bring one to the outside. Anything that is not a pair stays underneath your radical. Okay, let's look at the last one. The last one, we know the hypotenuse and a leg. That means we will be subtracting. So this gives us 42 squared minus 12 squared is equal to b squared. I could have called it a squared. It doesn't matter. Let's look at the numbers. 42 squared minus 12 squared, 1,620 is equal to b squared. Now we're going to square root. So I'm going to take the square root of 1,620. It is not a whole number, so I have to simplify. If they ask for exact length, they do not want this approximation. They will want to see your radical sign. That means exact. Okay, so I'm going to do the 1,620 is even. Let's divide it by 2. And I get 810. Oh, look up here, it's 810 also. So I'm going to divide it by 3. I get 267. Divide it by 3. I get 89. Divide it by 89, and I get 1. So this is the square root of 2 times 3 times 3 times 89. I still only have a pair of 3's to bring out. So I bring out the 3. The square root of 2 times 89 is left underneath. So my last step will be to multiply 2 times 89. I get 178. So this is 3 square root of 178. That is your simplified form. Anything that does not pair up, you multiply back together and leave underneath your radical. So we've got 3 more here. I will work through the first one with you, and then we are going to try the other 2 on our own. So the square root of 125. Okay, it's not even. 1 plus 2 is 3, plus 5 is 8. I cannot divide by 3. So I look at that last digit. It is a 5. I can divide by 5. I get 25. I divide by 5 again. I get 5. 5 is prime. When I hit 1, I am done. I am looking for those pairs. So this is 5 square root of 5. I pair up what I can. Whatever is not paired up is left underneath. Okay, pause the video and see if you can do the last 2 on your own. Let's see if you got the correct answer. I hope you tried on your own. Okay, 236 is even, so I divide it first by 2. And I get 118. 118 is even, so I can divide by 2 and get 59. Guess what? 59 is prime. 59 divided by 1, and I'm done. So this is 2 square root of 59. I bring one pair of the 2 out, and 59 is left underneath. Try the last one on your own now. If you didn't try this one, please try the last one. I hope you worked at it. 396, is it even? Yes, it ends in an even number. So I divide it by 2. I get 198. 198 is even, so I divide it by 2 again. I get 99. 99 is not even, but it is divisible by 3. So I divide by 3. I get 33. 33 is divisible by 3. I divide by 3 again. And I get 11. 11 is a prime number. So when I divide by 11, I get 1. 1, and I am done. What are my pairs? A pair of 2's and a pair of 3's. Remember, we multiply them back together. So this will be 2 times 3 square root of 11, 6 square root of 11. That is your simplified form. Now, you know you're successful when you can find those exact lengths of the right triangles, and you know how to simplify those radicals to get the exact length. So we worked on the Pythagorean theorem, and we worked at simplifying radicals.